Good day, everybody. Welcome back to my channel. I hope you're all fine. Please do not forget to subscribe, like, and share. So today we will be now doing Doppler effect. Now from November 2023, question 6. Now an ambulance is moving away. Please underline that because this away is gonna help you when you're using your formula there. From a stationary listener, it is very important because when it is saying stationary listener, it means that the velocity is equal to 0, meaning that the velocity of the listener is what equals to 0. With the constant velocity of that, the siren of the ambulance emits sound waves at the frequency of that. So meaning that this one, it is the frequency of the source, because the siren of the ambulance is the one that is emitting the sound waves. The listener detects the frequency of these sound waves to be 512,64. So now this is simply the frequency of the listener. Can you see it? It is very important to listen to your it is very important to read your statement, because now it is saying an ambulance is moving away. You underline away because away is going to help you to know which formula to choose between the two formulas. And then now from a stationary listener, now it is saying that it is simply telling you that the velocity of the listener is equal to 0 with a constant velocity. Then the siren of the ambulance emits sound waves at a frequency of 550 Hz, meaning that the frequency of the source is 550 because the ambulance is the one that is emitting the sound waves. Okay, then the listener detects the frequency of the sound waves to be 512,64 Hz, meaning that the frequency of the listener will be 512 because 4,64, because it is the frequency that is detected by the listener. The siren, the ambulance is the one that is emitting the sound waves. So basically this is the frequency of the source. Very important. Okay, so now you're simply gonna check. Now they're saying state the Doppler effect in words. So now you'll say the Doppler effect is saying like the change in frequency of the sound detected by the listener, because the sound source and the listener have different velocities relative to the medium of sound propagation. Okay, now let's go again. The second one says use the given information to calculate the speed of sound in the air, meaning that they're simply looking for that v. Okay, now I want to tell you something. In this topic, you are given 1 mark to write the formula. Okay, you are given 1 mark to write the formula, because it is the one that will tell you which one to you are given the default formula basically, like this one. So 6.1.2, this is the mark. FL equals to V plus over minus VL over V plus over minus VS, then everything times FS. So you are given a mark for this one. So this is the first mark out of 5 marks. Okay, then now the second one, it is now you're gonna write away. Then you're gonna write the formula. What is the formula for away? It is simply minus over plus. So FL equals to V minus VL over V plus minus VS, then everything times FS there. Okay, now what is the frequency of the listener? We got it as 512,64. Now we can substitute. So if 512,64 equals to, they want the velocity. This V is the velocity of the sound in this. It is the speed of sound in the air. Okay, and then what is the velocity of the listener? It is 0 because they said stationary listener. The velocity is the one that you are looking for. Then the velocity of the source, it is 25 meters per second. Then what is the frequency of the source? 512,64. 550, sorry, 550. Now we simply have V over V plus 25 times 550, 512,64. Then when we do our maths, we are allowed to start by dividing everything by 5, this one by 550. So we will have 512,64 over 550 equals to V over V plus 25. Cross multiply. 550 V equals to 512,64 V plus, what is 512,64 times 25? 512,64 times 25, 12816. And then now we are gonna subtract 550 minus 512,64. Remember, I'm using my calculator here, okay? So here we simply have 37,36 v equals to 12816. And then now what is 12816 divided by 37,36? The answer is simply what? 343,04. And remember that the speed of sound in the air doesn't have to be big number or small number. It must be between 340 to 343, somewhere along those lines. So 343,04 meters per second. And remember, guys, remember that in physics, especially the calculations that I just did, it is just maths. So you just have to make sure that you cleanse your maths there. So now 6.1.3 says, if the ambulance moves away from the stationary with a constant velocity with greater than what, now the ambulance is moving away. So the now is moving away. Now choose what is the speed of sound in the air. This one will simply what? Remain the same. This one you just have to, you don't have to think about anything, because this is the speed of sound in air. So this one is a constant, it doesn't change. Okay, the frequency of the sound waves emitted by the siren, now these ones will do what? Will also remain the same, because these are the ones that are emitted by the what? By the siren. So this one is also what? Remain the same. Now check something. The frequency of the sound wave detected by the listener, now these ones will do what? They will do what? They will simply what? Increase. Because now we are simply talking about what? We are talking about the frequency of the sound waves detected by the listener. Is it fine, guys? The spectrum of a distance that viewed from the is redshifted. So whenever you see the word redshifted, know that it is usually what? There is a low frequency and a high wavelength. Okay, before I start answering, know that there is a what? Low frequency, longer wavelength, meaning that the answer is gonna be what? Away from. So this one is what? Away. So redshift, away. Okay, now explain. So you simply say, you'll simply what? Say the lower frequency and longer wavelength will be detected at the end of the spectrum. Okay, because now check something. When it is away, you'll have what? A lower frequency and a longer wavelength. Okay, that's how it is, guys. Thank you very much. I hope you enjoyed.